Yeah, hello everyone. Hope I'm audible and the screen sharing is also working. Can you confirm that with a yes in the chat box? Hope I'm audible. Good evening, Dinesh. Good evening, Aditya. Good evening, Vaishnavi. Good evening, good evening. Yes, done that. So, yeah, I hope you enjoyed yesterday's session on recursion. Any doubts in that? Any doubts in that? You can also check it out again on YouTube. It's present in XLR's YouTube channel if you are having any doubts. Okay. You can always go through that and refer it. Okay. Recursion will take some more time and it's very important for you as well because when you solve some questions on your own on recursion, you will be able to understand what's the beauty of backtracking and how dynamic programming functions. DP is one of the difficult concepts, you can say, takes a lot of time to master. But if you have good foundations on recursion and all, you will be able to do that, okay, in DP. It will take you some time, but recursion is the starting point for your product-based company's journey. Done? That's it. Good evening, good evening, good evening, everyone. So let's continue. Let's get started. Lead code is the best option, not a good option. Okay. Lead code is the best. Done. Then you can look for geeks for geeks. Code chef is there. Lead code is the best. What old questions? What old questions you are talking about, Mohammed? Yeah, you do post it out. I'll check it out. Now, yeah, Code Chef is premium. That's for beginners actually. And if you can pay, then Code Chef is better. It will take you from basic to advanced, but previous class questions are same thing, one to n to one. You see here, we have gone through one to n to one. Then we have okay, seen Fibonacci. Factorial is there, sum is there. It's in the same one. Okay, it's in the same one. So you can note down those one to n to one displaying by using recursion. Some of them, product of them, and you see in functions we will not be solving any new, we will not be creating any new questions. Whatever questions that you have already solved, you will be converting that into functions. Every program you can solve it through recursion, theoretically every program you will be able to solve it through recursion. Okay, practically it's going to take some million years or so, as you have seen that number there. So any question, pick any question, pick reverse of a number, pick separation of digits, pick factorial. We have already did prime number, everything you will be able to do it through recursion. Solve every question through recursion. If you're having doubts, then you can get back to me. Okay, so that's it. You can either post it here or then LinkedIn personally. If you want. Done. Right, so we'll not waste any time since we are starting it a bit delayed. I'm waiting for people to join. Okay. Fibonacci series, I would suggest you to go through that lecture once again, go through the video one more time. Then, if you still have any doubts, we'll talk about it. Okay, just try and watch it one more time. Let that detail sink in. We'll talk about it again. Then we'll have a separate doubt session for it. Okay, so let's continue with today's topic. It's already delayed. Now, see, for today, we need to go through basics of insertion, deletion, searching, traversal, finding maximum, minimum inside an array, calculating sum, average, okay, even, odd count, reversing an array, rotating an array, second smallest, second largest, and merging two arrays also. We'll be going through all of them. These are the basics, okay, basics part one. Then tomorrow we will be like in the next session we will be going through a bit good questions. We will see Kadane algorithm. Okay, we will talk about strings as well a little bit. So let's go through that. Done. Right. So let's see here. Let's see here. So first of all, let's take an array input. Let's take an array input since we have people from other backgrounds and we are talking mainly about problem solving, I'll go with static input here. Okay, I'll not be taking dynamic input. If you guys know dynamic input, single line dynamic input we have, multi-line dynamic input we have, you can happily go through it. Let's take a static array. I hope you all will be comfortable with it. Okay, array is equal to, let's take some 10, 20, 30, 40, 50 also. We have five elements inside our array. Let me turn it down to dark mode as you guys prefer dark mode. I do, but yeah. You see, 10, 20, 30, 40, 50 we have. Good, cool. Now what do we have to do here? Here I want to insert any element. I want to delete any element. Okay. So how to insert an element? How to insert an element? Pretty simple. Inside arrays, we get some, inside list. Sorry, I forgot to mention. You see, list and array are two different things. In Python, we call them as list. But in your problem statement, whenever they are asking you any written exam question, they will only mention it as array. And no, Python doesn't have anything called array. Both are two different concepts, two different data structures completely. So we have list in Python. If you want arrays, we have it in NumPy. Okay, we don't have arrays in Python. So arrays are not there in Python. Inbuilt, it's not there. You need to go through NumPy also. So we have something called a list. And you know, Python is dynamic. This will save you a lot of time. I say Python is dynamic. Dynamic in the sense you can make it as big as you want, you can make it as small as you want, or simply speaking, you have seen my first presentation on introduction to DS. Let's say we have five elements inside our array. If I want to delete the first element, I need to move all the elements one step backward. I need to do this manually. Manually, I have to do it. But in Python, it does automatically. If you are removing this, all the elements will be adjusted automatically. Like you don't have to do it. Internally, Python will. So that's what very good about Python. So if you are someone who is starting your programming journey, who wants to focus on logic building, ignoring all these complex stuff and syntaxes also. So Python will be very easy. Done. So I got an instruction to go with Python actually since we have first years. So generally I prefer Java. So I'll take this to the management. Let's see what they will say. Maybe they will give you a poll or somewhere in their Instagram also. Vote it down. If you want, we can convert the language. I am comfortable with anything. Okay, I know multiple languages, but let's see. We have first years and all, so let's consider them as well. Now, see, in Python, we have some functions. Let's talk about the functions of list. Okay, we'll go through the most used functions. We have a function called length, and as you can guess, what will length give you? Length will return the length of the list. So returns the length of list. That's one thing. Now length is done. What about the next one? We have after length, we have something called max. So what will this max function do? Max returns maximum value. Okay, we will also go through the normal code of how to okay come up with max min. Very good, Mohammed. Okay, we have min. So min is going to return minimum value. Okay, minimum value. We have length, we have max, we have min. Okay, so yeah, those are all methods. You see, I'm talking about functions. Now, what is the difference between a function and a method? Can anyone come up with that? Why do we call functions as methods in Java? What is the difference between a function and method? Method is also a function. Okay, if we write a function, inside a class, we call it method. We call it method, but the functionality is same. Calling will be a little bit different. If we write a function inside a class, we call it method. You see, this is of list class. Let me name it as list only or li. Okay, li stands for our list or a new list. Done, or array list will say. Done, that's better. The naming is better. So print, I'll print type of list. Okay, type of this array list that we are using. Now see, if I print the type of it, I'm going to get it as class of list because Python is 100% object oriented. Here is an interview question for you. Okay. Java do you think Java is 100% object oriented? No, Java is 90% object oriented. Done. So Python is 100% object oriented. Yeah, feel surprised? Yes. So go check it out why Java is only 99% object oriented. That's your homework for today. So everything is an object in Python. You see, everything is an object in Python. Done. C is not object oriented. Okay, we do not have a concept called hoops in C. C is procedure oriented. Procedure means function. Okay, procedure oriented. We have two types of programming languages: procedure oriented programming languages and object oriented programming languages. We call it POP, procedure oriented programming. Okay, C is built over functions, not objects. C doesn't have hoops. That's why we had C++. C++ is the extended version of C or advanced version of C. Okay, so if you are someone who is looking to go back to C, no, C++ is the advanced version. You have to go to C++. That's how they are actually. You can study about the programming history as well. That's very nice actually. So you can learn a lot of things like how everything was created, how it is running. So in future, as you know, we are in a transition. We are going to get a lot of surprises within the next 2 years in programming. So that will help you understand the market. Now we have length, we have max, we have min. These three functions will be fine for us. Generally, I don't use functions or methods. I write my own functions method. Now see, let's talk about some methods. So we have a method called append. Append will add an element to the list. We have a method called extend. Extend is kind of like merges two lists. Okay. We have a method called index. Okay. You see, if I'm writing a method, I'm using a dot, right? I hope you all remember Java people. Whenever we go with, sorry, what's happening? Why the window, why this panel pops up? How to close it? Then so see, anyway. So I hope you all remember. You generally write system dot out dot println in Java. Na? So why dot? Because you are accessing okay system class. Inside the system class, the outstream. Inside the outstream, the println method. So we need to go with dot whenever we are accessing something inside of a class. Okay, this array list is an object of which class? List class. So that's why we are going with dot of it. That's why the method. Append we have, extend we have, index we have. Okay, count we have something called remove. We have something called pop. Okay. We also have sort, we also have reverse. As the name itself suggests, Python, you see, very readable, very easy. Now, what will append do? Append, as the name suggests, append adds a single element, adds a single element at end of list. Okay, I do have a presentation for them, but I generally use them for very beginners. We don't have much time as well, so this is enough. So we'll happily talk about them. What will extend do? Extend, you can say merges two lists. Okay, that will be a better term. Okay, merges two lists. Okay, adds a list as a single like multiple like adds all the elements of another list. Now what will index do? Index will search for an element. So you see, if you are entering a value, index will return the index position of the value. Position of value. You see, if value is not present, you'll get value error. Okay, if the index, the value that you are looking for is not present, you will get value error. Now what will counter do? Same thing, count. If you are entering a value, okay, count will return the number of occurrences of it. Returns number of occurrences of the value. Okay, if the value is not present, occurrence is zero only, will not get any error. Now what will remove do? Removes an element. Removes an element, and let me write something. Returns nothing. Okay, you see, if you are entering a value, removes the value, removes that element, but it is not going to return anything. Now coming to pop, you see, pop will take index. Pop will take index. So what it will do is removes value at that index, okay, and returns it. It is going to remove the value and return it. Don't worry, we will be going through the practical example for it. Once you are okay with that, then only I'll move on to the next one. Now coming to sort, what will sort do? You see, as the name suggests, sorts the original list. Original list. Why I'm writing original list? We have another function called sorted. So sorted returns a duplicate copy of sorted list. Returns duplicate copy of sorted list. Okay. So that's fine. In programming, you will be having, if multiple things are doing the same thing, they will be having a small difference. You need to understand the difference, then you will, okay, then you will be able to understand what's going on. Now, reverse we have, what will reverse do? Reverses the original list. Okay. As you have guessed, we also have a function called reverse. We have lots of things. Okay. You can also write functions, whatever programs that you are writing, you can make them as a function, you can make them as a method. That's also fine. We will be able to use them. So that's how things are. Every operation, as you have seen earlier, whatever piece of code that we are writing, we can convert that into a function. These are all converted by some other developer, not us. So we don't even have to go through them. We can write our own methods as well. Okay, so that's it. That. So now see, now coming here, now let's apply that to this one. So we have our array list. If I want to display it, so I'll simply go with print array list here. This is the original one. So let me write it in brackets, original one, right? So let me run it again. You see original list is equal to, where is the 20? 20 is gone. So 10, 20, 30, 40, 50. That's it. This is the original list. Now what do we have to do? I need length of it. So how can I get length of the list? Copy it. I'll paste it again. So here I'll be using the function. It is going to return the length of the list here, count of the elements. So how many elements we have? 5 elements. So it is going to give us the count of it. So what is the count? How many elements? 5. So length is equal to 5. Now max is going to give you the maximum element. Min is going to give you the minimum element. Copy it. Let me show that to you. Okay, max and min. Now for now I have simple array values. So in ascending or descending order, but you can also have a different mix of values. It will still give you max and min. Okay, you don't have to doubt it. You see max and min. What is the maximum value? 50. What is the minimum value? 10. That's it. So max and min also we are getting. Okay. That's it. This is length max min. We'll talk about sorted. Don't worry. So now let's see this methods and all. So coming to these methods. So what will append do? Append is going to add something at the end of the list. Append is going to add an element at the end of the list. So this is our original list. I'll be writing, you see print, I'll go, okay, trying to print append. So this is what I'm printing here. So here array list dot append of, okay, 10 to 50 we have. I'm going to append 60 there. Cool. Now let me print the, okay, original list before and after. So you can check it out. Now let me run this. We will be getting some output. You need to explain that to me. You see 10 to 50 we have. I tried to print it, so but we are getting none. But you can see here, 60 has been added. Okay, can you tell me why we are getting none here? Why we are getting none here? Yesterday itself we have seen functions, so why we are getting none here? Why we are getting none here? Can I? Do you have any idea? I'm trying to print this method. I'm getting none. What could be the reason? What could be the reason? What could be the reason? Hello, guys. Hope I'm audible. Hello, hello, hello. What could be the reason? Yes, very good. You see, we called this function, but this function is not returning anything. What we are doing, It is updating the original list. So if your function is not returning anything, by default it will be none. None means nothing. Okay. So none means nothing. We will not be getting any output. Very good, very good. I hope you understood that concept. Fine. So we have methods. Methods don't mostly don't return. Okay. When you print them, except this pop and all, remaining all will be doing the same. Okay. So they don't return the original list because they are not making a duplicate copy. Done. So append is done. Now what about extend? You see here, extend. I'll write. If I write a single value, if I do not have a sequence here, so if I run it, you see here, I'll be getting an error. Why am I getting an error? Why? Because I need to go with another list or another sequence type so that both of them can be merged. The original list and that can be merged. So if I go with a single value, you see it's saying it's not iterable. Now what are iterable? Sequence data types are iterable. Okay. So let me write a list of strings also. You see here. I'll go with Python. Okay, I'll go with C++. I'll go with C. We have three values here. I hope everything is fine. Yeah, done. Now if I run it, you see I'm extending the original list with another one. Same, this extend will also not return anything, none. And you can see the original list is being updated. Okay, so list is heterogeneous. You can have multiple data types in it. It's not like array. Array is homogeneous. So list is a different concept, as I said. Array and list are not same. So we don't have array in Python inbuilt. Done. So that's what extend will do. Now let's talk about index. You see here, index will just return you the index of it. So index will not change anything. No. So let's do that. Let's print it. Okay. Let's print our array list. Array list dot index of, what is the index of 30? Index of 30 is 2 here. You see here, let me clear everything. Index of 30 is 2. Done. Pretty good. Fine. Now, if I try to search for an element whose index is not present, let's say 130, what will happen? If the value that you are entering is not available, you see Python is robust. It is going to give you value errors. It will point out, it will give you the error there. Okay. You see, append just adds a single element at the end of the list, end of the original list. So it doesn't have to return anything. Okay, original list is modified here, right? Extend also modifies the original list, so they will not return anything. Now, when we are going with index, we are looking for a value. If the value is present, the function will return the index position of it. Now, why we are not returning the original list and all? Because whoever created these functions or methods, they made the original value only, okay, modified, like they updated the original value only. They didn't want that hassle of again storing it again. So if you are writing your own library in Python, you can have it any way you want. So the one who created it, he went with, if I'm using append, I'm adding a single element at the end of the original list only. So I'll not return anything. Original list will be automatically updated. If I'm using index, I'll search for the value, okay, inside the list. If I get the value, I'll return its index. Okay, that's the only way, because original list, there is nothing to be updated now. So that's why we return it. Done. So 130, if you are writing, so 130 is not present. So you see, we are getting value error. That's it. So the value that you have entered is not present. So that's why you're getting. Now that is about index. Now let's go with count. You see, let me take some multiple values. So 10, 10, 10, 10, okay, 20, 20, 30, 90 also, right? So let me go with count here. So array list dot count of, okay, what is the count of 10? What is the count of 10? How many times 10 is repeated? How many times 10 is repeated, guys? How many times 10 is repeated? Can you guess it? Or can you count it? 10 is repeated 5 times. You see, count of 10 is 5 here. Let me shorten this a little bit. Yes, count of 10 is 5. What about count of 30? How many times 30 is repeated? Run it again. 30 is repeated. 30 is repeated 2 times. How many times 90 is repeated? Or how many times 20 is repeated? Run it again. You see, 3. How many times 120 is repeated? 120 is not there now. Will we be getting an error? No, will not be getting an error. Okay, it's not repeated, so count is a zero. Zero. That's it. That's how simple it is. Okay, just very readable, very easy. You can also write it. It's not a big deal. Okay, we will also do that. Now coming to remove, what will remove do? Remove will remove an element from the array. It is not going to return anything. So let me show that to you. Okay. So I'll write remove of 10. You see the original, you see the final one. Okay. This is final I'll make. So how many tens are there? We have 5 tens. The first occurrence, every time we are going to start from left side, means the 0th index. You see here, the first occurrence will be removed, 10 will be removed. Okay, this 10 is removed, rest of the all the tens will remain intact. Okay, first occurrence will be removed. And are you getting anything written? No, that method is not returning anything, so none. If I go with pop, I need to take index, not the value. So let me take index. Let's say I'll be taking second index. So 2 is the index that is present here, that is 30. So 30 will be removed and it will be returned as well. Sorry, I need to write pop here. I need to write pop, that is the method. So if I run it, pop will take index. It is going to remove the value at that index and it is going to return it as well. So you see, you are getting the pop value. Pop means, I hope you might have heard pop sound. Okay. So in that manner, so whenever you are having pop, you will be getting something out of it. Okay. Something return. Done. That's it. So now let's say I did not write this pop index. You left it empty. For remove, for count, for index, you will be getting an error. But for pop, the default value is -1. Okay, let me write it. Default is -1. Default index is -1. Now you might ask, sir, what is -1? Okay, -1, you see here, coming to an array or coming to this list here in Python, 10, 20, 30, 40, 50. If you are not aware about it, we have two types of indexing. 0 we have, okay, we have 1, just a second, we have 2, we have 3, and we have 4. This is what we call as forward indexing or positive indexing. You can call it as you wish, positive indexing, or we call it forward indexing. Now again, coming back here, okay, we also have one more type of indexing. That is what we call negative indexing or backward indexing. The last value you can also access at -1. The second last value you can also access it as -2. Third last value you can also access it as -3. Okay. Fourth last value you can also access it as -4. Fifth last value you can also access it as -5. Okay. That's it. This is how you can access them. Done. Now this is what we call as backward indexing, or this is what we call as negative indexing. Okay. Backward indexing, or this is our negative indexing. Done. You see, so you might ask, sir, why not -0 is there? Why you're starting from -1? You see, plus or -0 is same. That's why -1. So one more question, sir, what is the need of it? Let's say you have a very big array. Okay. If you want to access the last element, you need to find out the length of it. You need to subtract minus from it. Okay. It's a big headache. Every time you need to do that. Now in Python, it's pretty simple. I want the last element. Last element index is -1. Second last element index is -2. Third last element index is -3. Fourth last element index is -4. That's it. That's how simple it is. So if I do not enter anything, by default, it will be -1. Means the last element will be removed. So let me reduce this here. You see, 10 to 50 only we have. Now if I run it, you see here 50, we are getting 50 has been removed. You can see the final list. Now one more thing. Let's say you don't even have any element, or you don't have the index that you have entered. You see, I have entered 10, not the element. This is index. Do we have 10th index? The indexes are only from 0 to 4. So if I don't have the index I'm looking for, I'll be getting index error. Okay, index error. Now why I'm showing you all these errors means when you are solving questions, you will be able to implement the basic logic. But okay, the syntax and all you will be able to write. But while executing it, when you are dynamically changing it, while you are performing insertions and deletions and all, you will be getting some errors. You need to read that error. Index error means the index that you're trying to access is not present. So you have to adjust the solution depending on what error you are getting. Okay, you have mistaken. So you will be trying to identify what went wrong, and you will be trying to come up with a solution for it. Done. So that is what reading errors is very important. When you are moving forward, errors will give you a lot of clarity. Okay, will teach you a bit more programming, and when you focus on errors, things will become a lot easier. So errors will teach you a lot of things so about your solution. Now that's fine. So pop is there. Now let me show you about sort. Sort, what will sort do? Sort will sort the original list. Okay, nothing will be returned. You see, I'm running it. Nothing is written, and the original list is already sorted. Let me unsort it. Let's go with some values here. Done. This is the unsorted list. Now run it. You see, it's not returning anything, but it is sorted. That's what sort will do. Now, what will reverse do? Reverse will reverse the original list. Reverse will reverse the original list. Reverse will reverse the original list. So let's run it out. Let's run it out. So reverse at the original list done. That's how it will be done. So these are all the functions. These are all the methods. Now let me show you what sorted function will do. Okay, reversed function is also there. You can explore more of them. You can use ChatGPT to give you all the functions that are present of list, methods are present of list, or you can even go through a lot of references are there. So you can do that. So sorted off array list I'll write. Done. So let's see. This function is going to return duplicate copy. You see here, this is the original list. This is the final list. Did anything change in the original list in array list? Nothing changed. So here you are getting a duplicate copy. So what did I write about sorted? What did I write about sorted? Returns a duplicate copy of sorted list. So does not modify the original one. Okay. That's it. These are about some basics of how a list is and what are the indexes, positive indexing, negative indexing, okay, and some functions, some methods so that we can perform some basic operations and all. Done. Clear? Any doubt up to this part? Any doubt up to this part? Understood up to this part? Understood up to this part? Understood up to this part? Yes, pretty basic. We have lots of other methods, lots of methods. Every program, they have converted it into a method. You don't need to know about all of them because we will be solving it on our own. Okay? So we'll be solving it on our own. Done? That's it. So now say, let's say we are going to write our own user-defined functions for it. Now let's see how to traverse the given array. So let's write our first program. Whenever I say write a program, write WAP in capital letters. Write a program to, okay, traverse the given array. Traverse the given list here, you can say. Traverse the given list. That is our question. So we'll start from this, then we will move to what happened actually. Yeah. We'll start from this, then we will move to searching. Okay, then we can move to make our own index. Then we can go with count. Everything is based on traversal. If you are able to access each and every element, you can search for an element that you are looking for. If you are finding that element, you can return that index. You can search the element entirely. Okay, you can count how many times you came across it, and sum and average also you can do. Okay, sum will also be done, and average will be also done. So that's how simple it is. Let's go through all of it. Let's take an array. Okay. Let me traverse through this in two different ways. As you have seen, array indexes will start from 0. Array indexes will end at length minus 1. So I can write a simple for loop. Let me take a small array. List is equal to 10, 20, 30, 40, 50, 60. Okay. Or we will say array list. Done. Now, indexes are ranging from index in range of, for index in range of 0 to length of list. Okay, length of the list. Like we should not be writing it statically. When I'm taking dynamic input, it should automatically scale up. Na? So we need to find the length only. For now, I know I have 6 elements only. If I write 6 here, that will be fine. Write it in this manner. Since you all know by starting like range default start value is 0, we can leave it. But for now, just leave it be. Let it be. So print index. So what will be the index? What will be the index? We'll be getting 0 to n minus 1. You see, we have 6 elements. So I'm getting 0 to length minus 1, 5. Now, if I want to get the value inside of it, okay, let me show you what value I'm talking about. Or if you guys are familiar about f string, generally I would like to print it in this manner. Okay, you see here, let me write an f string. So f string index is equal to index. Okay, the value inside index is, so array list of index is equal to array list of index is equal to array list of index. Don't worry, you will be able to understand it. Okay, now see here, I'll run it. So the index that you are accessing is 0. What is the value that is present in index of 0? The value that you have is, let me close it here. This is not required. Yeah. Now run it. Let me clear everything. Then this will be fine. Now see here. Index that you're accessing is 0. Array of 0 is 10. Index that you're accessing 1. Array of 1 is 20. Index you're accessing is 2. You don't want to play with the index. You want the value inside of it. You see, you will be going with array of index. That's what I'm trying to show you here. Ignore it. This is not required. So I'll just copy paste it on top if you guys want to do that on your own. So we are only interested in, see, I'm getting index. If I want to get the value inside of it as well, so array of list of index. That's it. That's how simple it is. Now run it, run Python file. That's it. 0th index 10, first index 20, second index 30, third index 40, fourth index 50, fifth index 60 it is. Now run it again, like you can increase your list, that will be happily doing it. Now that's it. We are able to access the index. We are able to get the value inside of it. This is one way of accessing list elements. Now let's see the other way. This is going to be easy. Let's say you don't have any work with the index. You only want to have the value. Index is not needed. Index is not important. Value is needed. Then we don't have to access index. We don't have to perform the calculation again and find the value inside of it. We can directly access the value. For, I call it element in array list. You can write it in this manner. This is the syntax. You can directly access the element that you have. For example, what are the elements we have inside our array list? In the first iteration, it is going to give us 10. Second iteration, 20. Third iteration, 30. Fourth iteration, 40. So on it will be. Now you see, run it. So I hope you can observe here, we are not accessing indexes. We are directly accessing the element. Now, why do I need this syntax? Why do I need this syntax? You see, why do we need this syntax is when we need the index of element. When we need to access index of element, we are going with this. Okay, when we will be going with this one? When, okay, value is important. Okay, value is needed, but not index. You don't have any work with the index. You are only interested in the value. Then you can happily go with this one. Now, you might ask, sir, why not this one? This takes more time. This generates a number, and this is going to fetch you the value inside the array as well. So it is going to make a few more operations. This one directly gives you the value. So if your objective is only to play with the value, go with this one. If you want to access the index as well, go with this one. So that's it. That's up to you. Okay. So a little bit of time change, but everything is according to your comfort. Yes, you can use enumerate. Lot of things are there. We have there. Lots of things are there. But as of now, we'll not be going into that direction. Okay, because that itself will take you 3 hours, 4 hours also. Okay? Now this is okay. This is fine. We are able to get the value, etc. and all. Now what's the next part? What's the next part? We need to come up with, okay, traversal is done. We are able to see two ways of traversing. Let's talk about searching. Okay. How can you search for the given element inside an array? And if you are able to find it, return its index. Okay. Return its index. So how we can do that? There are two types of searching. Can anyone tell me? Two types of searching in arrays that is pretty famous. So can anyone come up with it? Two types of searching. Two types of searching. Okay. Very good, very good. Linear search and binary search. Okay. Let me first show you the linear search. Linear search, as the name itself indicates, is sequential search or linear search. We will be going through every element one by one. Okay. Linearly, one by one. That's what we have. Okay. Since you guys are responding well, let me show you a good presentation for it about linear and binary. Okay. So let me show that to you. You guys are good students, so I'm getting good responses here. Searching algorithms we have. Yeah, done. So see here, do respond neatly. I'll like when students respond, I tend to do a lot more. Okay. So searching algorithm. So what is meant by searching? Searching means is the process of finding whether an element is present or not in a list of elements. Okay, that's what we are doing. So we have two types. What are those? The first type is linear. Second type is binary. These are the two types of searching we have. Now coming to linear search, let's talk about what linear search is. So what's the definition? Linear search is a method of finding an element by checking elements one by one. Okay, sequentially. We also call linear as sequential search. Now, what about the complexity? You see, we have three types of complexities. We have best case analysis, we have average case analysis, we have worst case analysis. Okay, what is best case? Big O of 1. What is average case? Big O of n. What is worst case? Big O of n. You might be confused, so don't worry. Once we'll go through linear search, at the ending, I'll explain you the complexity. I told you now in the second lecture, we will be talking about complexity in all the questions that we are doing. Okay. Yesterday you have seen in recursion, it was for Fibonacci, it is exponential. For the other values, if you have like for generating 1 to n or n to 1, that is n only, n number of operations you are doing. So that's how it will be. We'll talk about it. So don't worry. So see here. Coming to the algorithm of it, that's generally not required. We'll be directly going through the code part. So let's skip it. Done. So let's say the element that you are searching is already available in the array. So let's talk about it. So this is the array that I am searching. Okay. This is the array that I am searching. You see, I have a very big array. Done. These are the indexes and these are the addresses. Done. We'll address it as array, not list. Assuming we are going through C, C++, Java also. Let's talk about it as an array only. So sequential memory allocation, homogeneous elements we have done. Now here, I think the code will be in Java. Yeah, but fine. So think about it like an algorithm. So do not stress on it much. Let's say the key element that I am searching for is 90. Do we have 90 in the array? Do we have 90 in the array? Do we have 90 in the array? Which course you have registered? XLR course you have registered? I think it's better to contact the Sheetal ma'am or some other from the XLR team. Okay. So please go through them. I'm an instructor, so I don't have any details about it. I cannot help you with that. Okay. Right, so see. Done. So see, we all are high level machines. Our brains process a lot of things. You see, at this time, you are listening to a lot of things. Lots of things are happening around your surroundings. Okay. So you are high level machine. You have, in an instant, you have gone through all the elements. Your brain, your eyes have focused on 90. You have equalated this 90 and the value I'm giving you as well. Okay. So that is how everything happened. Now, whenever you want to communicate with this machine, you need to try and explain it like a small 10-year-old. 10-year-old in the sense, you see, I'll give you the algorithm. Okay, I'll drop it in the chat box. First thing, if I have to talk about the algorithm, so take an array input. Okay, that is our first value. Now, second value, take the element to search for. Okay, to search for. Take the value, whatever value that you want to search, whether it is present or not, value to search for. Now, as the suggestion says, linear search, we need to access each and every element. I have to write that step by step. How you are able to figure out 90? You have started from 27. You have compared 27 with the value that I have given. So that is what you're doing. So what I'll do is access all the elements of array, access all the elements of the array. Once you have accessed all the elements, then after accessing all the elements, what do we have to do? After accessing all the elements, we need to check whether the accessed element, the value that you are accessing, is equal to the value that you are searching. Okay. So check if array element is equal to value we are searching. Okay. It should be like a easy conversation between you and your friend. That's how an algorithm is. Okay. Simple English statement. So you and your friend, you might be asking, Array, how did you come up with the answer for this? He will be telling you the process. Na, Array, take this one and did this, and all. That's it. Simple English statement is algorithm. When you are writing a program, you should have that clarity with you. So now, what if the value becomes equal to that? So if it is true, I'll just write it a bit programmatically. If it is true, the element is present. So element found. If it is not true, after searching all the elements, you see, this is important. After searching, I have a habit of typing backwards. So after searching all the elements, okay, if still you did not find it, you have to print element not found. Okay, I'm not writing it that much technically, but this algorithm should run in your mind. Take an array as input. Okay, take an array as input. This is not binary search. This is a linear search only. Okay, so take an array as input. Take the value that you want to search for. Access all the elements of an array. Check if the accessed element is equal to the value that you are looking for. If it is true, element found. If it is not true, element not found. That's it. Okay. Now see here, this is what we are having. Let me close the controls and all a bit. Yeah. Now flag equal to 0, right? So what is flag? Flag is an indicator. What type of indicator? You see, you might have seen flare gun if you are playing PUBG also. It's an indication. Okay. You might have seen or listened in movies. People use white flag. White flag is an indication to surrender for peace. Okay, this is an indication. Now, flag equal to 0 is an indication that I did not find the element. So initially, I did not find the element. If I find the element, I'll make the flag as 1. Okay, there is other way to check whether you found the element or not, but this way will be a bit better because in other questions also you can use it. So flag equal to 0 we have. Now, as I told you, I'll be accessing each and every element inside my array. Okay, each and every element inside my array. So your array elements will start from which index? Index 0. Your array elements will go up to length of the index minus 1. Okay, ignore that different syntax that's in Java. But yeah, anyway, you guys are requesting. Some people, you might have some basics of C programming. So I hope this will be fine, except me for this particular question. Now see here, index equal to 0. So what is the value present at that index? What is the value present at index 0? Value present at index 0 is 27. So we are into the loop. After checking, 0 is less than the length of the array. So array of 0 is 27. Is 27 equal to 90? No. If condition is false, so if condition is false, it will not execute the if block. Then you see nothing else is there inside our loop. It will again go back and check the condition. Okay, after incrementing the I value, you see I value incremented to 1. I is still less than length of the array as well. 1 is still less than 9. So you will come here. Okay. 16 equal to 90. Is 16 is equal to 90? Yes, 16 is not equal to 90. So again, if condition is false, so you will be incrementing the I value. You will be again going back. The control will go back and check the condition. Is I less than length of the array? Yes. 2 is less than 10. So 2 less than 10 is inside the loop only. Sorry, inside the array only. Now here you will be checking if array of 2 equal to 90. No. So same process. It will keep on executing. Okay. Same process. You see 3 is not equal to. Array of 4 is not equal to. Now comes array of 5. You see here. Index value is updated to 5. 5 less than 10, yes, you will get inside the loop. Array of 5 is 90. Is 90 equal to the key I am searching for? Yes, that is true. So it is true. So did you find the element? Yes, I found the element. So flag will become 1. Okay, so you got the treasure. You have given an indicator. What is this indicator? As I told you. If you are moving to the left, you will have a left indicator, right indicator now in your vehicle. Similarly, it's an intimation. It's kind of like a signal. Okay. I found it or I did not find it because later on, after this loop, you see here I'm printing. I have to print whether the element is found or not. So that's what I have to do here. Now, I found the element. Do I have to continue searching for? No. I just wanted to check if the element is present or not. If I'm counting how many times it is present, then I have to continue up to the ending. My main objective is just to check if it is present or not. If it is present, element is present. So I don't have to continue. Now what happens if you continue? I only have 10 elements here. Imagine you have 1 crore elements. 1 crore elements. And the element that you are searching for, you found it at the 5th index. Will you continue for the remaining operations? It's going to be very costly. So once you have completed your objective, you don't have to continue. We should save our number of operations because the lesser the number of operations, the better, okay, it is going to be running. Okay, the better speed it will be. So flag equal to 1. Indicator turn to 1, indicating I found the element. I don't have to continue. I'll break. Break means I'll come out of the loop. Now I came out of the loop. I just need to check if flag equal to 1. Yes. So I found the element. So element found will be printed. You can also display the value as well. Okay. Element found and you can display it. Right. So now let's see without key. Without key in the sense same question, same array. You see I have the same array. Okay. Same thing. I have an array of 10 elements. We have the indexes on the top. We have the addresses on the bottom. 4 bytes per value. Now the element I am searching for 80. Do we have 80 here? 80 is present here. 80 is present here. Do we have 80? Do we have 80? No. You see, as I told you, we are high-level machines. You just an instant you have glanced at it and you have gone through all the elements. You have your brain compared each and every value with the value that you are looking for, and you came up with the result that it's not there. Okay, that's how solid proof that you are giving, right? We need to make the machine learn this. So in order for the machine to do that, it can also perform operations like you only, even better than us. So how we will be doing that? After going through all the elements. Okay, you see, I'll be starting from the beginning. Initially, flag equal to 0. I did not find the element. Okay, let me close this floating window. Initially, flag equal to 0. I'm starting from index 0. I'll check if index 0 is equal to the value. No, 27 is not equal to value. Again, go with next value. Okay, 16 is equal to value. No, go with next value. 35 is equal to value. No, go with next value. 50 is equal to value. No, go with next value. Okay. 79 is equal to value. No, go with next value. 90 is equal to value. No, go with next value. 21 is equal to value. No, go with next value. 15 is equal to value. No, go with next value. 81 is equal to 80. No, go with next value. 40 is equal to the value. No, go with the next value. But do we have next value? No, right? So if I increment I value becomes 10. You can see here I value is updated to 10. Now 10 is less than 10. 10 is less than the length of the array. No, na. So false it is. So you will come out of the loop. Now you see I have searched all the elements, but I did not find it yet. So flag did not turn 1. Na. So flag is still 0. If flag is still 0, element not found. So I'm checking if flag equal to 1. No, flag is not equal to 1. Then element not found. Not found will be displayed. Else part will be displayed. That's it. Understood this one? Understood linear search? Understood linear search? It's pretty easy. Pretty easy for any beginner. Anyone could understood this one. Okay. You never have to go through linear search again. That's how you should learn something. Whenever you're learning a concept, you should never have to revise it again. Okay, that's the way you need to master. Done? Right. So see here, let's talk about the complexity analysis. Now this is the value I have. So how many operations I am making? We go often linear it is. Now you might ask, sir, how did you say this, sir? Now let's talk about it. Let's say this is the array I have. Coming to best case analysis, okay, can you tell me what could be the best case in linear search? What could be the best case in linear search? What could be the best case in linear search? If the element that I am searching for is, presented the 0th index. Yes, if the element that I am searching for is the first element in the array, I don't have to perform all the other operations. Na? Only one operation, I got the answer. So best case is, doesn't matter how big your array is, you will always get the answer in one operation. If the element is present at first place, you got it. Very good, perfect. Now what is the average case? Average case is, the element can be present anywhere from 2, 3, 4, 5, so on up to n minus 1. Okay, anywhere in between. So if you calculate 2 plus 3 plus 4 plus 5 plus 6 plus so on by n, you will be getting big O of n only. Now we are not interested in these two. Why? Why? Because whenever we are talking about something, let's say I built this as a software. I'm delivering it to the client. The client is asking me if I have 100 elements, in how many operations I'll be able to find an element. Will you say, sir, you will get it in first operation? No. Can you say 10, 20? No. You have to make, sir, worst case, you will be finding the element in 100 operations. So maximum 100. You need to come up with the limit of it. Okay. You see in all our voltage ratings, etc. Everywhere you see, they give the worst case scenario, maximum voltage. You have to apply this much only, not more than that. Right? So we always talk about worst case. What is worst case? If the element I am searching for is present at the last index, I need to search all the elements. So how many operations? If you have 10,000 elements, you need to make 10,000 operations. So if you have n elements, you need to make n operations. That is what we call big O of n. That is what we call big O of n, linear. If you have 10,000, you need to perform 10,000. If you have 1 lakh, you need to perform 1 lakh. If you have 1 crore, worst case, you need to perform 1 crore operations. So linear search, you need to make n number of operations. If I'm giving you n elements, you need to make n number of operations. Okay? Understood this one? Why it is big O of n? Why it is linear? With input, it will raise. If you are giving me 1,000 elements, it will take maximum 1,000 operations. Okay? Understood this one? Why it is big O of n? Clear? Clear? Clear with it? Clear with it? Clear with it? Yes. Now, guys, now listen. Did I talk about the analysis of it like I equal to 1, this flag, how many operations it will be? You see, this will be 1 operation. This will be 1 operation. This will be n operations. Okay. N plus 1 we can say. This will be n operations. This checking will be n operations. This will be only 1. this maximum worst case we are talking n operations, this will be only one if it is executed. Did we talk about all these numbers and all? Is it needed? No. Even if you talk about that, but if you write it, it would be, let's say, I'll roughly write it. Let's say this is 3n plus 5 if it is ever executed. Okay, 5 or 6 or so 7 something. We will reduce, we will remove the less dominant terms. We will remove coefficients. It is simply big O of n, that's it. Okay. In linear search, if you have 1,000 elements, you need to perform 1,000 operations. 1,000 times you need to search for. Okay. That's how simply we'll talk about. So as a beginner, you will be having lots of doubts in your mind. If you look at the clarity of the presentation that I have, and I have a separate clarity presentation, I cannot convert it much. I face a lot of issues only. Okay. I wanted to learn about each and everything. You need to pursue design and analysis of algorithm. Okay. There are good universities, Harvard, etc., and all online they offer. If you want, you can go through them. If you are very interested in that, but generally, if I have to talk about for competitive coding or for programming, it's not needed. You have 1,000 elements in array, maximum in linear search, 1,000 operations. That is n only linearly. If you increase the input, number of operations that you need to know do also increases. That's how simple it is. You can close it there. Okay, don't have to worry about it. So you will be having a subject called design and analysis of algorithm. So make sure you give your heart to it. It's very good actually. Done. That's it. This is about linear search. Now, what are the advantages of linear search? Let me show you this. Okay. Linear search is very simple. Linear search works on sorted and unsorted data. Every list you will be able to apply linear search, but it is only good for smaller data sets only. It doesn't need any extra memory. If you are going for a very big array, it is going to take a lot of time, and it is nowhere near compared to binary. You might ask, sir, you like why are you saying that much big words? Nowhere near compared to binary. You will understand that once I show you binary. Okay, so yeah, let's go through that. So that is about linear. I hope you are done with it. Understood linear? Understood linear? Understood linear? I want to exit from here. Yeah, exit. Understood linear? Let's perform linear search. Let me take an array list. Array list of, let's go with that previous value that we had. This one I'll take. Okay, done. I'll ask the user to enter the value. Okay, int of input, I'll ask the user to enter n. Okay, user is going to enter n value. Okay, value from enter value to search. Sorry, I had a long day, so cannot think much. Yeah. Now what I need to do? Are you interested in index? Yes, I want the index to be printed as well so that we can execute the index method as well on our own. I'll be accessing each and every index. For index n, range of length of array list. I'm accessing each and every index. Let me show that to you first. Print index. So how many values you have? I have a total of 9 values. So how many indexes it will be? It will be 8 indexes. So 0 to 8 you are getting. See, what is the value present at that index? If you want to access it, I need to write it as array list of index. Done. Now run it. Let's say value, this is not needed as of now. You see here the values. We are getting one value at a time. The loop will run for 9 times, and every time we are getting one value. Okay, so now what do we have to do? The operation is pretty simple. I need to check. You have seen the presentation, and also I'm not dragging on this much. We will quickly jump to binary. If the value that you are accessing at the index is equal to the value that the user has entered, then we don't have to continue. We can simply break it. Okay. Before breaking it, what I can do is I can take the indicator, flag is 0. Flag is 0, what is the meaning? I didn't find the element. Didn't find the element. Okay, done. So if I found the element, I'll make flag equal to 1. If the condition is true, so what's the meaning? I found it. I found it. Okay, so that's it. I'm breaking it so that we don't have to continue through the next operations and it will automatically increment. So in for loop, you don't have to worry about that. We also have for else, etc. and all, but I don't want to get into those syntax since other people are from Java. Let it be. So if flag is still equal to 0, then you did not find the element. Print, okay, element not found. Element not found. Okay, we'll go with 404. Any web developers here? I'm a web developer, full stack web developer. I love development. Else, a flag is not equal to 0, then print element founded. I can also print the index. What is the index? What is the index? You see, when you come out of this loop, when you break it in the middle, the last value that is stored in this variable is nothing but the index symbolically. I'm writing it as index only, the name as well. So that's pretty easy for us. Index will be the index it will be. Now let's run it. Let's check it out for 12. So do we have 12? Yes. What is the index of it? 7. You see element found at index 7. Let's run it again. Do we have 3? Yes. 3 is present at 2 places. The first place is 0. So 0, I am finding it. I'll not continue again. This is the best case. Now, worst case is 35, present at last place. Now, worst case is also this one. Let's say, do we have 100 here? No. It will go through all the elements of the array. You had 9 elements, it will go through 9 elements. You had 10,000 elements, you will go through 10,000 elements. So that's it. 404 error. Okay. Element not found. This is about linear search implementation. Linear search implementation. Now let's go through binary search. Let's go through binary search. Yeah, good evening. Let's go through binary search. Sir, where do we, I saw a doubt also. Where do we use linear? Everywhere. Like for small data sets, for sorted and unsorted data, you can happily use linear. Okay, you will understand the difference between linear and binary once I go through binary. Okay, done. Linear done. Give a thumbs up. Give a thumbs up. We'll go to binary. Give a thumbs up if you understood linear. Give a thumbs up if you understood linear. Now you asked about use cases. No, this is the use cases. Some small use cases you can talk about. Okay, small use cases you can talk about. Done. Perfect. 200 successfully found. Yeah. Yes, 200 success. Yeah, I missed development. Now let's talk about binary search. Now coming to binary search, what is binary search? You see, it's in the name itself. By means two. In our array, whenever we are searching for it, we are going to reduce the number of values by half. Listen very carefully. I'll show the proof for it as well. This is going to be a visual spectacle for you. Okay. I hope you have seen my recursion, how good it is. You would have never seen something like that. Almost all every presentation, starting from the beginning. Binary is also something like that only. No one has done it, okay, apart from me. So I'm the only person who has this type of content in the world. Okay. Now see here, binary search. Coming to complexity, we have 3 cases: best case analysis, average case analysis, worst case analysis. Best case is big O of 1. In the first operation only, you are able to find the element. Average cases, big O of log n. Worst case is also big O of log n. You might be confused. We will go through it. At the ending, we'll discuss about complexity. As I said, we will be talking about complexity everywhere. So that will be fine. Now let's get into it. So we have binary search. You see, coming to the algorithm, as I said, this is not that much required. So let's skip it. Okay, done. I'm hoping you have basic idea about it. But anyway, I'll teach you from the beginning. Let's say the element that we are searching for is already present in the array, in the list. So I'll be taking an array. I'll be writing the indexes on top of it. I'll be writing the addresses on bottom of it. So let's say I have a very big array. I cannot show you a very big array here, but imagine we have a very big array, 10,000 elements, 10 lakh elements, 1 crore elements also. Okay. I have 14 elements here. Indexes are ranging from 0 to 13. Okay. 0 to length minus 1. Now the element that I want to search is the target. Target equal to 32. Okay, here we have 32. Very good, perfect. Now, what do I have to do in binary search is, in binary search, it's an implementation of two-pointer technique. Now you might ask, sir, what is two-pointer technique? You see, programming is pretty simple. It's in the name itself. Okay, so two pointers at a time. If you are focusing, if you are accessing two values, that is what we call two-pointer technique. Okay, so I'll be taking a pointer called low. Let me hide this video panel. You guys are mad about the attendance list. You'll get it, so don't worry. Wait for some time. If you're only here for attendance, don't be. Okay, that certificate, if you are getting without any knowledge, is of no use. So see here, two-pointer technique. We have two pointers. We have a pointer called low. We have a pointer called high. Low will be pointing to the starting index. High will be pointing to the last index. Okay, starting index and ending index of the array. Done. Pretty good. Pretty cool. Now see here. Now see here. Initially flag equal to 0. You guys know why I write flag. Okay, why I'm writing flag here. Indicator. Initially I did not have the element. Flag equal to 0 means I did not find the element I'm looking for. Done. Now see here we have a while loop. While this condition fails, I'll be keep on executing it. Right? I'm checking if low is less than or equal to high. Low value is 0. Less than or equal to 13. Yes, low is less than or equal to 13. Correct. Now you might ask, sir, how did you come up with this one? We'll talk about it in an iteration. So let's get into that. So low less than or equal to high, condition is true. So we will get into the array. So coming inside the array, calculating mid. So mid is equal to low plus high minus low by 2. You might ask, sir, why did you write it this manner? Simply, could you not write it low plus high by 2? You see, in other languages like C programming and in Java, integer has a fixed range. So when I am adding to integers, there is a chance that it can go out of that range. So we will be getting an error. In order to avoid it, we will write it in this manner. But in Python, integer, it's dynamic. So you can make it as big as you want. It's automatic. Na? So I hope you all remember, if you do not have enough space, you will go for long int. Okay, do you remember in C programming in Java? So in order to avoid that integer overflow, I'm coming up with this small equation. So do keep that in mind. I'll show you the calculation. What is 0 plus 13 by 2? That is 6.5. We are taking integer value, so that is going to be 6. If you do that as low plus high minus low by 2, you will also be getting the same number. So nothing new here. Okay. So it's all basic math only. So if you just divide this function, let me maybe scribble it here a little bit. So here we have low plus, if you write it normally, high by 2 minus low by 2. Original low minus half of it. You will be having half low by 2 plus high by 2. This is same only, na? Low plus high by 2 only. So just making it easy so that we will not get integer overflow. I hope you understood this line. I'm hoping. Now, mid value is 6. Now, what is the value present at mid? Mid is 36. Now, we will be checking. We have three cases. If the target that I am searching for is present at the mid value of the array, is it present at the mid value? Yes, it is not present at the mid value. 32 is not equal to 6. So, both are not equal. So, here, there is a very important point. We can apply binary search only on sorted list only. Okay, I forgot to mention that point at the beginning. Since this array is sorted, we can only apply binary search on sorted list. Sorted list, not unsorted. Unsorted, it will not work. Why? Why means this is an algorithm. We have designed it in that manner. Okay, this is a recipe. This is the ingredient that we are having. Now see here, the element is not equal to the value that you are searching. Now there are only two cases. Either the element will be on the left half or either the element will be on the right half. How you will decide it? Since everything is sorted, the element that I am searching is 32. 32 is less than 36. It's not greater than 36, it's less than 36. Because it is less than 36, I know that after mid, I have all the elements which are higher than 36. So I know that I'll never be able to get the value on the right side. So I don't even have to search on the right side. So what I'll be doing, I'll not be searching on the right side. So the maximum index that I'll search is 5. So high, I'm going to modify. I'll not be searching up to 13. I'll only search up to 5. Why? Why? Because my target element is less than the accessed mid. Since everything is sorted, the value is less than it, so it will be present on left half only. So I don't even have to go through right half. You see, in one iteration, you have removed half of the values. Okay. Now, that's it. This is the last line of the loop. So control will again go back, will again check the condition. Now, what is low value? Low value is 0. What is high value? High value is 32. Okay. High value is 5. Okay. So 0 is less than or equal to 5. Now you might ask, sir, what is this condition is doing? You see, we have low searching from left side, high searching from right side. Both are approaching where the value would be located. If the value is present, you will get it. If the value is not present, low and high will cross over each other. Okay, low and high will cross over each other. Low is coming from left, high is coming from right. From low left onwards, it's searching. High right onwards, it's searching. If you did not come across it, both of them will cross over each other. We'll see that ending condition as well, so don't worry. So why people are raising hands and all? Okay, I'm getting that notification a lot. Please contact any admin or so, Kavya. I am an instructor. I don't have any details about any of that. Okay. Please contact the managers also. Whatever number is mentioned in the posters, you can contact them and talk about it. I don't have any details about that. We don't have attendance. Okay. So listen to the class. If you are interested in attendance, please leave it. Okay. If you are present up to the end of the session, somewhere they will be posting the attendance link. So if you are only here for attendance, don't bother. Okay, happily leave. What will you do with an empty certificate without knowledge? Done. So low less than or equal to high. Done. So next thing, mid value we have to calculate. So what is mid? Mid is low plus high by 2. Okay, so if you calculate the mid of 0 plus 5 by 2, that is 2.5. So integer value of it, that is 2. So mid is 20. The value inside mid is 20. Now you are checking if the target is equal to mid. 32 is equal to 20? No, 32 is not equal to 20. Is 32 greater than 20? Yes, 32 is greater than 20. So will I have 32 on the left side of the mid? No, I'll have it on the right side of it. So now what I'll do is low equal to mid plus 1. Okay, I don't have to search on the left side because I know that I will not have the element on the left side of it. So see here, I'll be searching on the right side. Now that's it. So one of these conditions have executed, so the remaining will not execute. So that is how if else conditions work. Now, last line of the loop is executed. You will again go back and check the condition. Low is less than or equal to high only. 3 is less than or equal to 5. Find the mid. 3 plus 5 by 2, that is going to be 8 by 2, that is 4. So we are checking if target is equal to mid. 29 is equal to 32. No. Is target is greater than mid? Yes. Target is greater than mid. So low equal to, we will be going with mid plus 1. We don't have to search on the left side of it, including the mid. Now you see low and high are equal. Last line of the loop. So low less than or equal to high. Yes. Low less than or equal to high. Now low plus high by 2. Low plus high by 2. You will be having 5 plus 5 by 2, that is 5. So target is equal to the array of mid. Yes, target is equal to array of mid. 32 is equal to 32. You will be able to find the element. Done. That's it. You got the element. If condition is true, so flag will be 1. Flag will become 1. Flag will become 1. And we will be ending our loop. We will be breaking it. So we'll come out of it. Now, you see here, what is the indicator? If flag is 1, you found the element. Yes, flag is 1. I found the element. If flag is not 1, element not found. Let's see that scenario as well. without target. I'll fast forward this a little bit, okay, since you have understood everything. Top of it, we have indexes, bottom, we have addresses, we have all the elements, okay. We have 14 elements, 0 to 13, the indexes range will be. Target is 40. Do we have 40? You can quickly check that. We don't have 40. Now, see here, we have our same binary search logic. I'll be starting off at low equal to 0, high equal to length minus 1. Low we have, high we have. Now flag is 0. Initially I did not find the element, so flag 0. Now low less than or equal to high. Yes, 0 is less than or equal to 13. Mid is 0 plus 13 by 2, that is 6. So the value present at mid is equal to target. No, it's not equal. Is your target less than mid or greater than mid? Yes, target is greater than mid, so you don't have to search on the left side. You have to go with the right side. So left side. Up to mid, I'll never be able to find the element. So left side, I don't even have to consider. Again, last line of the loop, go back and check the condition. Low less than or equal to high, correct? So mid equal to low plus high by 2. Again, low plus high by 2. We are calculating mid value. Okay. Mid is 57 we have. So like 10. Value inside 10 is 57. So 57 is equal to 40. No. 40 is greater than 57. Target you're looking for is greater than array of mid. No. Target is less than it. So we will not find the element after the mid. So high value is not needed. High value, you need to reduce it. So high equal to mid minus 1. High equal to mid minus 1. So this is the maximum that we have to look for. Okay. We are eliminating half of the values every day. Now again, last line, so again go back, check the condition. Low less than or equal to high, that's correct only. Then what you have to do? Low plus high by 2, that is 7 plus 9 by 2. You're going to get, sorry, 8. So 16 by 2, 8. So what's the value presented at? 41. 41 is equal to the target? No. Target is greater than 41? No. Target is less than it. So left side only it will be present. So high equal to mid minus 1. Now see, right side I don't have to search. Now again, go back and check the condition. Low value less than or equal to high? Yes. Low is less than or equal to high. Mid equal to low plus high by 2. So low plus high by 2, 7 plus 7 by 2, you will be getting 7 only. Right? So mid is equal to 7. The target that you are searching is equal to area of mid? No. 40 is not equal to 39. Target that you are searching is greater than 39. Mid? Yes. Target is greater than it. So what will happen? Let's look very carefully. Low will be mid plus 1. Since we have figured out we don't have it on the left side of it, we will move to the right side. Low equal to mid plus 1. Okay. Now left side it will not check it. Now it will go back and check the condition. What did I tell you? Low will come from the left direction. High will come from the right direction. Okay. When the element is not present, low and high will cross over each other. Okay. If low and high cross over each other means you do not have the element. Okay. You just have to simply stop there. That's it. That's it. That's how simple it is. Now you see, we came out of the loop. Flag is 0. Yes. Flag is not 1. So what will happen? Element not found will be displayed. Okay. Done. So what binary search does is, it works on sorted list. It works on sorted array. It will search for the element that you have. Okay. By eliminating half of the elements at a time. It will narrow down that range. It will narrow down that range. You see, 40 should be presented between low and high only. Right. This is an important observation. We will be using this later on. So element not found. That's it. Now let's talk about complexity analysis. Now let's talk about complexity analysis. Complexity analysis. Okay. See here, coming to complexity analysis, see here we have this entire list. Now log n we called it. Why log n means? Let's talk about it. So see, best case analysis is the element that you might be searching would be the mid value. So the first mid only, first operation only you could get it. So big O of 1 it is. Now average case, let's say I have this n. n elements. In the first iteration, how many values I'm going to reduce? Half of it will be reduced. Done. N became n by 2. In this n by 2, again, I'm going to reduce by half. So this n by 2 will be reduced by half. So n by 4 will be. So this is second iteration. Done. That is nothing but 2 power 2, 4. In the third iteration, this n by 4 will be reduced by half. So n by 4 by 2. Okay. In the next iteration, the same thing. In the next iteration, the same thing. So k iterations if you are having, so you will be able to get it in if you are having k values, k number of elements. Sorry, if you are having n number of elements, you will be able to get it in log n number of iterations. Confused? Don't worry, you will be able to understand it. This is the average case, and worst case is also the same. Okay, you will get something like average will be in between 1 to log n. The worst will be log n. So don't worry, we will be showing you a small good mathematics. Yes, I know math, you guys don't like it, but our mathematics is the language of universe. So let's say if I have two elements, okay, what is log of base 2 of n? Log of base 2 of 2, that is 1. If I have four elements, what is log of base 2 of 4? Log of base 2 of 4 is log of base 2 of 2 power 2. Keep the 2 before your logger, log of base 2 of 2, that is 1, so that is 2. If you have four elements, it will take you two operations. Let's say in the previous iteration, I have given you how many values? I have given you 14 values. So let's say I had 16 values. I'm just writing it roughly. 16 values. In the first iteration, it will remove 8 values. In the second iteration, it will remove 4 values. First iteration it is. Second iteration, it will reduce it by half. Third iteration, it will reduce it by half again. So it will become 2. Fourth iteration, it will reduce it to 1. Okay, that's it. You got the element there. That's it. You got the element there. So how many operations you got it? Imagine, just visualize. 8, 16 values you have. Okay. First iteration, 8 will be eliminated. Second iteration, remaining 4, like 8, half of them, 4 will be eliminated. Remaining iteration, you are left with 2. Next iteration, you are left with 1. That's your answer. So if I have 16 elements, binary search, okay, will give me like it in 4 values, 4 iterations. If I have 32, 5. If I have 64, if I have 128, 256, 512, 1024, 2048. Slowly, if I increase the number, see here, if I have somewhere around 3 crore 35 lakh 54,432 elements, how many operations will binary search take? It will take 25 operations. Or you can increase this a little bit. You can increase this a little bit. Let's talk about the next value. Let's write it averagely. So 3 crore 35 lakh na 7.7 crore. You have to do 26 operations. Okay, let's talk about 15 crore also. 15 crore means you have to perform 27. 30 crore means 28. Okay, 30 crore. Crore we are talking about. 60 crore means 29. 120 crore values if you have, you need to perform 30 operations. That's it. See how huge the difference is between linear search and binary search. In linear search, if you have 120 crore operations, 120 crore values, you need to perform 120 crore operations. That's why linear search only works for small data set. If you have a bigger data set, okay, if it is sorted, you can perform the operations in very less number. You can perform it in log n if you are using binary. See how huge the difference between binary and linear. Okay, logarithmic and linear time complexities. Hope you understood the how big it is, how big it is, how big it is. Done, done. Any doubt till this point? Any doubt till this point? Understood how good binary search is compared to linear? Understood how good binary search is compared to linear? Okay, that's how huge the difference is. Okay, that's why linear search is nowhere near to binary. Logarithmic is best, one of the best complexities you have. Now, what are the advantages? Binary search is very, very, very fast compared to linear. It reduces searching by half. Complexity is logarithmic, which is beautiful as you have seen. 120 crore, logarithmic of 120 crore, you have 30 operations if you have 120 values, 120 crore values. It requires very fewer comparisons. You have seen that. Very efficient for largest sorted data sets. But sorting the data sets is another headache, but fine, we will be able to do that. Disadvantages, binary search will only work on sorted data, and sorting the data will take extra time. Not suitable for linked list because in linked list we don't have any indexes, etc. and all. Now we cannot magically access a random index. Okay, so that's why works only on arrays and all. Insertion and deletion are difficult in arrays, so let's leave that. So that's I think extra point added. What are the applications? See some values I'm displaying here. These are the applications of where binary search will be used. Okay, binary search will be used. Done. I'm going through your messages. Just I hope you are going through the usages of binary search. Usages of binary search. Done. Done. Right. That's it. That's about applications of binary search. We'll leave it. We'll not go through quizzing. We'll discuss some problem solving also. Okay. Let me connect my charger. So let's solve binary search in LeetCode only. Okay. So I'll be opening LeetCode. Let me go through one of my accounts here. You can search for LeetCode. You can search for LeetCode. This is LeetCode. If you do not have an account in LeetCode, do create one. LeetCode is one of the best platforms to prepare for product-based companies. Okay, where people generally from all over the world. Just let me connect my charger. I'm having charging issues. Just a second. Just a second. I'm having charging issues. So maybe the port is completely burnt or so. Done, done, done. Right. Right, so fine. I've resolved the charging issue. Done. So let's see. Yeah, as it is, as I told you, LeetCode is one of the best platforms you can prepare for competitive coding. You can create an account and you can verify your email as well. That's basic stuff, so I'm not going to get into that. So coming to LeetCode, see here how many questions we have. We have more than 3,800 questions, and if you see all the tags that we have here, all these big companies, meta companies, we call, okay, whatever questions that were previously asked in online assessment, we call it OA. For all these companies, they don't have regular hiring. Okay, if you are skilled enough, you will be able to ask for a referral for someone, and you will be able to showcase your skills in your resume and all. You will be shortlisted. You will be getting a call. You will be having an online interview, online assessment. We call it OA. where interviewer will be present. He will be giving you a problem statement. You need to clarify all your doubts, ask about constraints, etc., and all that you need to know. Okay. Then you have to tell him the different ways of solving. Then you don't need to be a pro at DSA for AI/ML, but AI/ML requires good mathematical thinking and reasoning. So you have to be good at math. So DSA will give you good idea about optimizations. DSA, irrespective of programming, let's leave it. Everyone needs it. It's for thinking about it. Okay, so it will develop the way that you look at things. So you need it, definitely need it for AI/ML. But for AI/ML, the mastery is a bit different. So let's not talk about it for now. OA, online assessment, as I said. So you will be given a problem statement. You need to explain different ways of solving, and you are how to explain which way you are selecting and why you are selecting it, and make sure all the edge cases are passed. So in this platform, you will be able to get different topics. Let's say you are preparing array for today, okay, or string, or hash table, or math, or dynamic programming. Whenever you have completed an algorithm, for example, we are going through binary search. I hope you can also spot binary search somewhere here. Binary search, yeah, see, binary search, you have seen it. Two pointer technique, it is a part of. So if I click on binary search, I'll be getting n number of questions which can be solved by using binary search. There are total how many questions? 333 questions we have. Okay. Some of them are different, but anyway, you got 333 questions. Select some 20 or 25 or 30 questions in it to solve with binary search. Not any question. Good number of questions. Quality over quantity. If you are first year or second year, you will have lot of time. So spend your time per day, do one question or two questions per day. Okay. Binary search, if you are taking 10 days or 20 days or even a month, let's say for every algorithm you took a month, still you will be able to get into these meta companies. That's how easy it is. Okay. So let's get started with the first one, that is binary search itself. So the number of the question is, let me search it. The number of the question is 7 odd, right? I'll introduce to the layout of it. You see here, this is how the layout will look like. This is the dynamic layout. You can get double-edged arrows and you will be able to move everything. Now see, left side, you will be having the problem statement. You will be having the description. You will be having the sample input output as well. And below that, you will be having the constraints. So all this is important. You can see this is binary search. Acceptance rate is 60.5. So let's say if 100 people have submitted it, 60% of them were able to submit it in the first go itself. So kind of like how many attempts you made with how many successful attempts it is. So 60% of all the submissions were successful, 40% failed. Okay, that's it. So see here. You will also get similar questions below that. You can see similar questions. If you are not getting any idea about the question, you can go through hints. For this, hints are not available. You can see which topics it has. It will be having array, it will be having two pointer, it will be having binary search. So binary search is a part of two pointer, so leave it. That's it. So similar questions you can solve it after solving this one. If you want to get involved, you can have a discussion tab here, or if you want to submit a solution, you have solutions tab here. Done. Now let me go through the code tab. So code tab we have, I'll reset everything just like any other code editor. Now here we don't have to take the array input. Let me make it full screen. Here we don't have to take any array input. So what is happening here? What is happening here? Okay. You guys are very concerned about. See, data science is also mathematics. See, programming is math itself. You need to be very good at math to develop good complex algorithms. It's all functions, etc. Instead of us doing calculations, we'll make the machine do. And for you to design an efficient algorithm, you need to know which one is efficient. No, so graphs will only give you that. Math will only give you that. You have to be good at math ultimately. You have to be good with data, good with numbers. Okay, so yeah, that's how things are. Everywhere you will see math. Now see, yeah, they are giving us nums as input. They are giving us target that we need to search for. Now what do we have to do? We need to check if this target is present in the array or not. If the target is present, go through the problem statement. Given an array of integer nums, which is already sorted in ascending order. Yes, they are giving us nums. This is already sorted array. So indication for us to use binary search. If they are saying it's sorted, two-pointer technique can be used effectively, easily. Binary search, happily. Okay. So an integer target is given. What do we have to do? We need to write a function to search target in nums. They have already given the function. We need to complete it, go through the body of the function. If the target exists, if the target is present, return its index. If it's not present, return -1. They will check internally, okay, about that. We don't have to do it. And what did they say? The constraint is make sure it runs in log n. What is the algorithm which runs in log n for searching? It is binary search, or you can see the constraints here as well. It's not that big, but it's fine. 10 to the power of 4 is a big value. You can use binary. Linear also you can use here, but don't think you will be getting time limit exceeded for this. Let's go with binary here first. Okay. So binary search, as you have already seen, what do we have to do here? First start with low. Low equal to 0. Next start with high. What about high? High equal to length of nums -1. Now you have seen the visualization two times. I hope you will be very familiar. While low is searching from left side, high is searching from right side. While low less than or equal to high, I need to calculate mid. What is mid? Low plus high by 2. Okay, use brackets. Low plus high by 2. Otherwise, division will be performed first. So operator precedence we have na board mass. So low plus high by 2, add low and high, then divide by 2. Done. Very good. Low plus high by 2 we have. If the target that I'm looking for is equal to the nums of mid. Mid is an index order. Nums of mid. Now, why did I write it length of nums -1? If I have 10 elements, the last index is 9. So 0 plus 9 by 2, you will be having that 4 as well. So target equal to nums of mid. Lose the connection. Just a second. I'll just verify if I have Wi-Fi connection. Yes, Wi-Fi is connected. Yeah, if target is equal to nums of mid, then what do we have to do? We don't have to do anything. Return target. Now you have seen whenever I find the element, I'm returning it. Returning means you will not execute the rest of it. So you don't have to go with flag, you don't have to go with break, etc. And also happily return will end it. Right? If target is not equal to array of mid, then what do we have to do? If target is greater than nums of mid, sorry, not array of mid. If target is greater than nums of mid, then you need to search on the right side. Right side in the sense, low value will start from mid plus 1. Up to mid we have searched now, we'll go with one value extra. If not, if target is not equal to or not greater than, then definitely it's less than. Less than means it will be present on left side. So high equal to mid -1. Okay. So it will keep on doing it. If the value is present, it will return its index. Okay. So sorry, they said return target now. Sorry, return index now. So return, what is the index? The index is mid. Sorry, my bad. If you are done with it, okay, let's say low is not less than or equal to high. Done. You will come out of the loop. Once you are out of the loop, it indicates you did not find the element. If you found the element, it would automatically return the index. So if you did not find the element, what do they want you to return? They want you to return -1. That's it. That's it. Now run this. This is the run button we have. Run it. It will check it out for these two sample inputs that we have. Okay, sorry, I think I made some mistake somewhere. There is that line number 7, it's saying. Nums of, sorry, it is integer, no? So double divided by 2. Okay, run it. So both the sample inputs are fine. Now submit it. Now submit it, you see. LeetCode will give you how many test cases. LeetCode will have a lot of test cases. For this one, it is 47 test cases. It gives you runtime. So the code that you have given ran in 0 milliseconds and gives you percentage. Percentage in the sense, if 100 people have submitted this, you are beating all 100% of them. You are in the top 100%. You got full marks for it. If you are getting 30, 40, 60 or so, then you need to improve your algorithm. Improve, there will be another way of solving which would be better. So you need to improve it. Okay. That's it. That's about binary search. Now, after binary search, as I said, you can go through other similar questions. Similar questions in the sense, I'll give you one more question in binary search that you can go through it. I hope this is fine. Any doubts till this part? Binary search is fine. Can you do this? Can you do this? Can you do this? Done? Now note down the question numbers for your assignment. Yes, you can attempt the same question as many times as you want. There is no constraint for it, but your acceptance rate will take a hit if you are not submitting it properly. Your personal acceptance rate, let's say in that it will be very low. Okay. You see, ultimately moving forward, everything will merge with full stack. AML, full stack, everything will be one single stack only. Okay. So everything has demand. First thing, learn a programming language, get started with development, do whatever interests you, learn a bit of everything. Okay. So if you something interests you, you will be able to spend more time in it. Let's say you want to do AML research, you are very much interested in those machine learning and LLM things and all. Get into that, you will have a bright future. Okay, that will be something that you love and you will be able to get good high position in it. Everything will have demand, and the people who enjoy coding will only sustain, not the one who looks for high package, who wants to learn it only for the money part. If you love it, you will automatically get good income out of it. Yes, if the array is unsorted, you cannot use binary search. Binary search is only for sorted. Binary search is only for sorted. Done. Yeah, done then. So note down the other questions then. Let me show you that my battery is low. It might die at any point. Note down the other questions. Okay. The next question that you need to go for is question number 35. Question number 35. Search insert position. Just note it down somewhere. Question number 35. Question number 69. Question number 34. These will be good. Question number 35, question number 69, question number 34. These three are fine. 35, 69, 34. Okay. Try to solve them. If you have any doubts, get back to me. Okay. We'll talk about it. Fine. That's it. That's it for today. We cannot discuss another question in the remaining 2 minutes. So we'll close. As a beginner to create a project, so go with Merge Stack. Learn Merge Stack. If you are very beginner, you start with Python a little bit. Python has good libraries. You will be able to build small GUI applications onwards. And Python's Django framework, full stack Python Django comes with a inbuilt admin panel, so you will be able to see results very quickly. DSA in Java definitely. Okay, learn Java from top to bottom. Do DSA in Java. People are generally mad about C++, but Java, DSA, perfect combination for your career and development. So no other questions asked. Blindly go with Java DSA. Okay, don't be stuck in selecting which language. Okay, to do get started with DSA. Just get started with Java and go ahead with DSA with it. If you are comfortable with Python, go with Python and then DSA. Okay. Ultimately, if you ask me, Java, very good for your placements, very good for your projects, very good for your career. Java DSA. That's it. Ultimate. No other questions. If you trust me, then Java DSA. Do not think about anything else. Go with Java DSA. Clear? Done. That's it. So I'll see you tomorrow. Bye bye. It's 9 o'clock. We'll go through some more array questions tomorrow, maybe a bit of 2D array. Okay, wanna see spiral matrix? Tomorrow I'll show you. Your assignment will be understand how matrix works, how to take input, how to display matrix output. That will help you to understand the lecture better. If you want product-based companies, you should have basic idea of matrix. If I'm discussing basic matrix, then it's of no use. This session is of no use. So see how to take matrix input, how to display matrix output. That's your assignment. Yeah, thank you. Thank you for listening patiently and being such a good audience. I'll see you tomorrow.
Yeah, sir, just to add, not tomorrow, on Monday. Yeah, so dear students, be like, we're not going to have any sessions on Saturday, Sunday. So Monday will be our next class. So happy weekend. Keep coding, keep growing with Excel. Thank you, team. Bye bye. Why, sir? Who is asking where? Yeah, happy Shivratri. Thank you, Ritika. Saturday, Sunday, no class. Next class is on Monday. Thank you.